I am going to discuss about, I'm not going to spend too much time on the research that I usually do. I want to focus on potential opportunities for collaboration with other faculty. So I want to talk about my research tools that can be applied in collaborations. Again, this is my background. I did my PhD at UT Austin. I've been here now 8 years, so I'm becoming a senior person here. So I am very proud of my students who have graduated at UCF or my formal universities, and right now they are all pursuing research careers, and some of them are in industry. We are also, my research group is also looking at developing several graduate classes, and we are also starting a new master's program with Rosen College and College of Engineering, which is a MS program in travel technology and analytics. I am serving as the program director right now. We started the program at the advent of COVID, so we had some initial setbacks in terms of enrollments, but I think with as the economy and the tourist economy is opening up, I think we are hoping to see more students registering and applying for that program. So my research interests are driven based on quantitative approaches. We, in our research group, we do a lot of work on econometric modeling. We develop experimental designs for stated preference surveys. In terms of the thrusts, right now I want to focus on for this talk are on two thrusts. One is, how are individuals adopting technology? As all of you are aware, smart cities is happening. Different areas in different engineering areas are looking at adding new sensing technologies, adding new tools to monitor different environments. I am interested in looking at how is this technology adopted across different individuals or different communities. What is the comfort among individuals and communities in allowing this technology? Because again, there are different concerns. There could be privacy concerns. There could be what is the benefit equity concerns associated with it. And can we use these sensing devices to provide personalized guidance? So a simple example would be, can we have a fusion of different sensors installed across urban regions to provide individuals with better transportation routes, better transportation modes, and better connectivity? So for example, if you want to encourage the reliance, moving away on the reliance on automobile as your main mode of transportation, if the main challenge is finding appropriate alternatives. So can we use the sensing technology and data that is coming up to provide this personalized guidance? And even if you provide that guidance, adoption or bringing about change in people's behavior is not straightforward. So how do we get that buy-in among individuals to change? So what my research team does is it develops quantitative frameworks to address so-called soft metrics in engineering. So in some contexts, AI approaches are very applicable to some of these data when you have large databases. But when we are talking about understanding individual preferences, having a behavioral framework and going towards identifying what are the causes or causal factors affecting those decision process will be useful. For example, if you think about scenarios where data is not available, when you're talking about will individuals purchase autonomous vehicles when they become available, what is the price value that they'll place on in terms of pricing, in terms of the different features, Wi-Fi accessibility, and other so on and so forth. We cannot use artificial intelligence approaches because data is not available. So one thing we need to do is we need to build what are called stated preference surveys. These are surveys where we are asking individuals about preferences of alternatives that don't exist. Again, obviously, it's not as simplistic as asking somebody, would you purchase this vehicle if it is available? What we want to do is create a choice context where they actually consider the different alternatives and their corresponding attributes and then choose their choices. So we are making individuals go through what are hypothetical choice scenarios, which are as close to the reality as possible in the future. So in that way, instead of asking direct questions and using those to make conclusions on what people will behave, we're actually developing analytical models on cleverly created stated preference surveys to understand what are the trade-offs that people make when they make these choices. The second area of interest that I'm looking at is evaluating equity implications. As technology evolves, we want to see, is the technology evolution worsening the current inequality in the society? Can we look at urban region level metrics? Can we use different tools of agent-based simulation and people's behavior-based analysis to understand how we can study technology evolution and its impact on equity in that sense? So, for example, if you're looking at electric vehicles and autonomous vehicles, usually these technology will benefit early adopters, and from data we can see that the early adopters are right now what we would call high income households. So if autonomous vehicles emerge into the market and they are improving the safety, because driver error can be corrected in these vehicles, so they are making them safer for these individuals. But either these individuals are adopting risky driving behaviors because there is inbuilt safety in the car, so that could actually affect people who are not driving autonomous vehicles. So there is this effect of, say, inequity in safety. So people who own older cars, which are likely to be lower income and minority individuals, who are likely to sustain more severe injuries in terms of a crash. So similar discussions can be made about air quality, because electric vehicles are producing less air pollution. Now the benefits of these policies are likely to spread or worsen inequity in the society. So how do we evaluate different policies in a rigorous framework to understand what should be done to avoid worsening inequity in the society? So that's the thrust that I'm interested in talking about today. So in terms of technology adoption, vehicle ownership is a big area where whether people will continue to buy vehicles as we do right now, or will individuals shift towards a shared fleet system. So in our research group, we've been working a lot on understanding how people are using ride-share alternatives such as Uber and Lyft, and is that making changes? Is that influencing their behavior enough to change their vehicle fleet? So for example, if you live in a city like New York, you used to own 3 cars in your household, but what you do is you say, because of the ubiquitous availability of Uber and Lyft and other medium like that, you might only decide to own 1 car, but use shared vehicles for other activity purposes. So these are the 2 potential pathways that we are examining in terms of purchase and shared fleet adoption. Now, who will purchase? How many will purchase? At what price people will purchase? Or at what pricing plan are people comfortable using shared fleets? Are questions that need to be addressed. And I think stated preference surveys will be the way to look at these questions. So an example of a stated preference question would be something like this, where we are asking individuals what kind of vehicle they want to purchase, what are the prices available for those vehicles, what features are available. So the idea of a stated preference survey is these attributes have different levels, and we want to estimate the impact. So we want to see the value of $1,000. So if you provide Wi-Fi connectivity on the vehicle, are people willing to pay $1,000 extra for the car or $5,000 extra for the car? And how does that change based on income configuration and so on? These trade-offs, if they are accurately established, they will provide both the policymakers and vehicle manufacturers ideas on what should they focus on in building this technology and adding these features into their vehicles. So another example context can be route choice. If you're looking at how people are moving from one location to another, there are different possible routes that are available. Travel time is a factor. All of you, when you're considering coming to work or traveling anywhere, you look at toll price option and not, and you also look at routes that are more reliable. So all of these attributes can be considered into the state preference design, and we can estimate trade-offs for that. So there are different applications of such design in different engineering areas. I think that's what I wanted to discuss. So if you think about attributes and attribute levels, so travel time and reliability can be measured in different levels. So for example, if you're talking about travel time reliability, you can have very low reliable roadway, medium reliability, high reliability. So there are multiple levels for each attribute. So if you want to design a good stated preference survey with only 5 sets of questions with 5 levels per attribute, the number of possible comparisons explode very fast. And in some cases, the number of attributes are more than 5. They could be 10 or 15. So how do we do a design where these comparisons can be meaningfully considered is an important element of the design. So we will not be able to do a full design where all comparisons are passed through the survey process. So what we do is we adopt what is called factorial design process, where a fraction of the comparisons are considered, but they are optimized in a way that those comparisons are enough to provide the full spectrum of options available to the individuals, so that we can create the models that can analyze the trade-offs effectively. Okay, so I see this approach can be effectively utilized in what technology can be used in medicine, evaluation of safety technologies into vehicle design, again vehicle feature selection and pricing. So again, colleagues in different fields in mechanical engineering or biomedical engineering might be interested in some of these studies. So I'm interested in potential collaborations if there is a need for developing such factorial design and analysis of that based on advanced models. In terms of the second piece that I've talked about, in terms of equity impacts, it's going to take a substantially long time for vehicle fleets to change. So we want to have electric vehicles and autonomous vehicles, but the adoption is going to take time. So as we go through this transition, we need to make sure that there are policies in place where the negative impacts of these technology do not influence the lower income households and vulnerable populations in a negative way. So we want to be proactive about this and address this inequality. Towards this end, what we want to do is, again, we are not trying to look at these aspects qualitatively. We want to do quantitative analysis by focusing on synthetic populations generated with behavior. So we use census data to build urban populations. We're talking about 4 million, 5 million agents who are embedded with characteristics of income, household characteristics, their employment and other characteristics. And then we process these simulations to make decisions. So these are agents making decisions on what kind of cars they want to purchase. These decisions are made based on observed data or data that we have analyzed in the past to process the different factors that affect the choices. Using this, we can evolve the do nothing scenario of what happens to electric vehicles or connected autonomous vehicles into 2030, into 2040. And we also can simulate scenarios where how the evolution of vehicles will happen if there are policies in place. So for example, it might be beneficial to the society to actually have low-income households purchase some of these advanced technology to offset the societal cost. So we will do a quantitative analysis of what policies work and at what cost do they work, and what is the impact of that in the context of inequity as we evolve into the future. So these simulations will provide us answers on what kind of rebates will work, what incentives will benefit vulnerable population, because again, budget is limited for all of these choices. So some of these analysis can be conducted, overlaid with economics considerations to arrive at solutions that are beneficial to the society. Okay? So again, these are the two topics I wanted to talk about. In terms of the future, in the short term, I'll be looking at some federal applications, looking at some stated preference survey designs in different parts of tech engineering. Also, we are working on the urban systems modeling aspect, where we're looking at how electric vehicle penetration is resulting in potential inequities and how do we address that through different scenarios. We're looking at that. And in the long term, I would like to build collaborations with interdisciplinary so that we can go for larger grants such as the NSF ERC program and other effects. Again, the work that I discussed is obviously based on my research teams and various faculty collaborators and so on. I just want to acknowledge that. And again, I'm happy to take any questions at this point.